Good afternoon. So today I will talk to you about urban playgrounds in future climates. And this presentation is based on a study that was published last year. And I will start briefly saying why we focus on urban playgrounds. Well, they are important outdoor spaces for families that live in the cities. And they also outdoor play provides a range of benefits that are essential for children's health and development. But even though it's essential, children actually tend to spend less time outdoors these days. And current playground designs focus more on strategies that look at minimizing the injuries due to impact, for example, fall, but good quality shade, thermal comfort, and the risk of skin burns are not always considered. And actually, insufficient shade is quite common in playgrounds. And even if it's present there, not necessarily covers the entire play area. And a recent assessment that was done for New South Wales Playground found that 19% of them had no shade whatsoever. And more than a half of the assessed playgrounds didn't have enough shade on the longest summer day. And no shade means that playgrounds will be less likely utilized on sunny days. And also, the empirical heat knowledge is limited. And we often measure unshaded playground surfaces with very high temperatures. And this is an example of an image that was taken in Western Sydney during a heat wave in year 2020. That playground had no shade at the time, was mostly covered with bark mulch, and many surfaces actually reached quite high temperatures. An example here, you have a rubber surface that reached almost 100 degrees in full sun. And someone will probably think, well, that was a heat wave. No one was on that playground at the time. Well, that's true, but these high surface temperatures are not limited to these extreme heat wave conditions. They occur on much cooler days. And warm and hot days are not limited to the summertime. They actually frequently occur in spring and autumn when playgrounds actually most likely will be utilized. And this is actually a graph that shows you the number of days when the daily maximum air temperatures were above 27 degrees. And for some of these years, this number of days actually is within most of the year. So they actually occur quite frequently. And if warm days and hot days occur frequently, so will the hot surfaces, creating thermally uncomfortable, in many cases, dangerous conditions throughout the year, not just the summertime. So, will the current design actually impact negatively the accessibility of playgrounds and their thermal comfort in the future, further reducing the time children spend outside as the temperatures increase because of climate change? Well, we examined this question by testing different common playground materials in a study that was done in Kingswood. And we pretty much wanted to learn their thermal impact. So this was done last year and over 2 days in Western Sydney location. And these 2 days had very similar ambient conditions. They were both sunny, there was no cloud cover, and they were warm with the daily temperatures in the low 30s. And firstly, we measured these surfaces in the sun, and then we introduced shade the next day. And that shade blocked 97% of the light. And we actually took thermal images of these playground materials. Each of these materials was photographed every 30 minutes throughout the day. And we used 28 playground materials in this study. And you can see them here on this image. There were actually 24 surfaces made of 4 types of rubbers, and they're abbreviated here as the SBR, EPDM, TPR, and TPV, and you have the full names just next to them. We also had 4 synthetic turfs, and as a reference, we measured a grass that was growing nearby. And the rubbers had 3 distinctive colors, and they were grouped into blue, green, and more of these beige and brown colors. And within these colors, there were also different tones that we classified into dark, intermediate, and light. While the synthetic turfs had a different length of blades. They were either long, medium, or short. And here's an overview image for some of the rubber materials that were measured in the sun. This image was taken at noon, when the ambient air temperature was below 30 degrees. As you can see on this thermal image, there's quite a variation in surface temperatures between these materials. And for some of them, for example, this dark blue and green material, the mean surface temperature was around 70 degrees, while this white rubber that was just next to them had 40 degrees. And then when we were shading them and we excluded the impact of solar radiation on the surface temperature of these materials, we found a reduction in the temperatures. So the surface temperatures of these materials were very similar regardless of their color. And this image was also taken at noon with similar ambient air temperature. And here, the rubbers were roughly 30 degrees in temperature, and the synthetic turfs were only 5 degrees warmer. So this is only one single point in time that these measurements were done, but I also have here a graph that shows you the maximum surface temperatures for selected materials in this study that were measured in the sun. And the panels A, B, and D are the different rubbers, and panel C are the synthetic turfs. And at the beginning of the day, between 8 and 12 o'clock, there was quite a rapid increase in the surface temperatures of some of these materials. And in fact, the synthetic turfs here worked faster than other materials. So they actually reached these maximum temperatures earlier in a day than other materials in this study. And also the dark surfaces were warmer than light ones throughout the day. And most of the materials reach their maximum surface temperatures between 12 and 2 o'clock. So among the hottest that we measured were the synthetic turf with the longest blades, but also this dark blue SBR rubber. While the coolest ones were the white TPO and the light beige EPDM rubbers. And the green grass that was growing nearby had very similar temperature to these coolest materials. And I don't have here results for the shaded materials, but when they were shaded, as you've seen on the previous slide, the temperatures were reduced. They actually linearly increased throughout the day, and they closely reflected the ambient air temperatures. So just to briefly sum up these findings, natural grass was the coolest. Then we had the different types of rubbers, with the TPO being the cooler and SBR the warmer type of rubber. But the hottest surfaces that we measured were the artificial grasses. And based on the findings from this study, we recommend the following. Shade should be provided in playgrounds, ideally over the entire play area. Shade can efficiently reduce surface temperatures of materials that will otherwise heat up significantly in the sun. It will reduce the risk of skin burns and protect against harmful UV radiation. And it can be introduced as artificial shade structure for this immediate shade, but incorporation of natural shade for the long-term cooling strategies should also be included, because trees with large and dense canopies not only provide shade, but additional cooling of the air. And when shade is not possible, we should select materials with thermal properties that minimize the absorption of solar radiation and retention of that heat. So for example, selecting light-colored materials should be preferred. And for the areas where the impact-absorbing surfaces are needed, we should look first into the TPO rubbers. They were among the coolest. And our last option should be the SBR rubber because they were among the hottest. And the unshaded synthetic turf, well, it should not be used in playgrounds, especially in hot climates. We frequently find that these surfaces reach very high temperatures. Thank you very much.
Thank you. Thank you for this nice talk.